Hello, welcome to Computer Tech and More. This is another one of my series of my future plans. So I want to make a little CFM, so that's cubic feet per minute chamber. So it's a little cone shape, compresses down, and this would fit a 120 millimeter class fan. And what's really cool about this design is that I would have these conversion panels to then make it able to go from 120 class to a 92. So it just would slot right in, and it's got these holes and would slot right into it. And it would be able to go down to an 80 millimeter class fan so that it would be able to get you data on your small form factor cases that use, I don't want to say non-standard, but less common fan sizes, so that I could get you data on which ones actually are the best to buy in that size category. Beyond that, I want to build one that is for 180 millimeter class fans, and it would compress down. So you'd see these pegs. So the 180 would be able to just slot right in. And then it would go to, let's see, 180 to 140. So again, it would peg right in, and the 140 would fit right onto these pegs. So it'd be just slot, slot, perfect fit. And then it would also have one from 180 to 120. Except that's the wrong one. 180 to 180 down to 120. So going back to the main overview, and actually either one of them would, where is it? Would work. So the idea is that 180 millimeter class fan is basically the largest that you're going to fit in any normal computer case, because 120s or 200 millimeters tend to be just too big, and they're actually being blocked off by portions of the case, so you're not actually achieving that full 200 millimeter class criteria. So the 180 would be like for the Fractal Design Torrent, which I think is kind of the maximum. So all the air would be able to push down and it wouldn't expand. But when you have 120, the 120 would fit kind of right here in the middle. I believe I sized this exit hole to be about 120 millimeter class fan. So you get the idea. It would have room to expand and slow down a little bit. So you'd really be able to see the difference between 180s and 120s and other class fans that shoot air off to the sides, but it would be more focused than my case simulation test. So it's kind of halfway in between. So I would have another series of tests down just a simple tube. So there would be no expansion whatsoever for a standard CFM type test. So this way, this sort of testing does test how concentrating airflow is for 180s down to 120s. And then the other one would be, where is it again? Oh, 160. I made a slot for 160. For 120s down to a 60 millimeter class fan, which would be right here. So using like data extrapolation, you could actually create a way to relate 120s and 80 millimeter class fans to 180 millimeter class fans, but that would be kind of a stretch. But yeah, I really want to like expand the type of testing I can actually achieve with this channel. And then I want to fully upgrade my case simulation chamber. So this is a little bit over 180 millimeter class hole right there. So it could actually fit a 200 millimeter class fan with very little obstruction. And then it would have these removable posts. So it'd be hole spacing for 180s, I do believe. And then these slots would vary based on what sort of testing equipment I have. Whether I have a fan style one, it would just kind of slot right in, or I have a kind of tube based one, in which case the way that these are laid out. And I'd add one additional spacing in there. So we'd have a 9-inch, a 6-inch, we would have a 3-inch, an 11.5, and a 14.2 inch. So a little bit different than what I'm doing right now, but overall kind of the same. This, I plan on it being like 3D printed. So I would need to get that sorted out. I don't have a 3D printer right now. And it uses the same spacing as the other one you saw for the converters, basically. But I would be able to size, this would just slot right on, covering up that test chamber for the case simulation test. So just blop right on, and so I could have consistent testing all the way through, which would allow me to relate 120s, 140s, 180s, 200 millimeter class fans all to one another to give you the best, like telling you which ones would be the best for your actual computer case, which is kind of what I'm trying to achieve here is, hey, which ones should you actually spend your hard-earned money on, and how do they compare with one another? But yeah, that's what I want. I would make, it's got the standard sizing, so I could use the same one for this chamber as I could use for this chamber, so that everything is streamlined, simplified, and, well, quote unquote, perfect. But again, all of this is me needing to get to the next level, and the next level is, well, help support from viewers like you or some kind of sponsorship. Ideally, the sponsorship would be like an instrument manufacturing company that wouldn't mind providing me 1, 2, 3, 4, 5 or more anemometers and a high quality microphone. That would go a long way, because that's probably the biggest expense here. You know, I don't know if this talking about how much it's going to cost is a good thing or a bad thing, but I just want to like say this because it's like I'm taking it seriously. I want to get to this point. I want my testing apparatus to be less janky and more streamlined and better overall. So I want to prove that, you know, I have plans in place to show that I am taking it seriously. Otherwise, I wouldn't have spent my time designing this thing, modeling it up and going, this is what I want to make. Anyways, thank you very much for watching my channel. Whether or not I get the funding, I'm going to keep making videos the way I am right now. If I get to that next point, we'll get these improvements with even more test data than I currently do. Thank you for watching. If you got suggestions for more content, please leave it in the comment sections down below. I have a Patreon page. Join me as a YouTube member. I also have a Discord page. All linked in the video description down below. Have a great day, and I'll see you next time.